Today we're looking at our notes and our trigonometric ratios. Remember, the battle cry for trig functions is my SO, CA, TOA. When I'm looking at the triangle that I have here with angles A, B, and a right angle at C, and the lengths of the legs, the lowercase a and lowercase b, and the hypotenuse is the length, the lowercase c. When I'm talking about the sine function, that's that SO, the SOH. It reminds me that the sine of an angle is the ratio of the opposite side of the angle to the length of the hypotenuse. So the sine of angle A is that little a over c. If I want the sine of angle B, I want the opposite side, the little b, over the hypotenuse c. The cosine of an angle, that's that CA part. It's the ratio of the length of the leg adjacent to the angle to the length of the hypotenuse. Remember, adjacent means next to. So if I'm looking at the cosine of angle A, it's the leg adjacent, the length of B, over the hypotenuse. If I want the cosine of angle B, it's the adjacent, the little a, over the hypotenuse c. And if I want the tangent, that's that TOA part of my SOHCAHTOA, the tangent of an angle is the ratio of the length of the leg opposite the angle to the length of the leg adjacent to the angle. I don't use the hypotenuse at all in my tangent function. So if I want the tangent of angle A, I want the side opposite, which is the little a, over the adjacent, the little b. If I want the tangent of angle B, I want the little b over the little a. In the next section, I'm looking at writing ratios for my sine, cosine, tangent ratios, given the little triangle LMN here. Notice that the legs are length 6 and 8, and my hypotenuse is the length 10. So no matter which trig function I use or which angle I look at, my hypotenuse is going to equal the 10. If I look at question number 4, where I want to find the sine of angle L, my sine I know is my opposite over my hypotenuse. So if I look at angle L, my opposite side will be 6, my hypotenuse will be 10. So my fraction is 6 over 10, which reduces to 3/5. If I want it as a decimal, that will be 0.6. My cosine of angle L, my cosine function, is my adjacent over my hypotenuse. If I'm looking at angle L, the side that's adjacent is my 8. My hypotenuse is still my 10. So my fraction is 8/10. That reduces to 4/5. If I wanted it as a decimal, it would be 0.8. My tangent function is always going to be my opposite over my adjacent. That TOA. If I want the tangent of angle M, the opposite is 8, the adjacent is 6, and 8 over 6 reduces to 4/3. If I wanted to write that as a decimal, that would be about 1.33. When I'm using my calculator to find my trigonometric ratios, I need to make sure that my mode is in degrees. So again, in my calculator, I need to hit my mode button and make sure that the third one down is not radians, but degrees is highlighted. If radians happens to be highlighted, go over to degrees, hit enter so that that is highlighted, and then you can easily put those numbers in your calculator. I can get the sine of 33 degrees by just hitting my sine button, 0.54. I can get the cosine of 47 degrees, and I can get the tangent of 81 degrees. It's just number crunching and putting the answers down on your paper. For the last 4 questions on this page, we're going to be writing an equation and then using the trigonometric ratio to find the missing lengths that we're looking for. So if I'm looking at triangle BCD, the angle I'm given is angle B. They want me to find the length of segment BD, so that's where I'm going to put my X. When I look at this triangle, I realize that the length BD is my hypotenuse, and the length they've given me of 11 meters is not next to or adjacent to my angle B, but it's opposite. Because of my SOHCAHTOA, I know I'm going to use the sine of the angle because I have opposite and hypotenuse. So my equation becomes the sine of 62 degrees equals 11 over x. When I solve that equation and I cross multiply, it's like interchanging the x and the sine 62, and I end up with x equals 11 divided by the sine of 62. That's just a number. You're going to number crunch that in your calculator to get the length of segment BD. So in my calculator, I'm taking 11 divided by the sine of 62, 12.458, rounding to the nearest hundredth, is 12.46. And we're in meters. If I look at question number 11, the angle I'm given is 38 degrees. I have my hypotenuse, the 26. They want me to find QP. This is where the X is. I notice that that X is next to angle Q, which makes it the adjacent side. If I have adjacent and hypotenuse, I'm going to be using my cosine function, that ka. So to set up my equation, I'm going to have the cosine of 38 degrees equal to my adjacent side, that's my x, divided by my hypotenuse, which is 25. I'm going to cross multiply, and I'll end up with x equaling 25 times the cosine of 38, and I'm just crunching that in my calculator. Cosine 38, and that gives me 19.70. And I'm in millimeters. Make sure when you're checking these answers that you're getting things that make sense. If you're looking for a length of a leg, it should be smaller than your hypotenuse, and so that's making sense. If I'm looking at question number 12, I'm given a 27-degree angle. I have the side right next to that angle. That's my adjacent side. They want me to find the side RS, which is farthest away from the 27 degrees. That's my opposite side. Notice I don't need this hypotenuse at all in this problem. I'm not looking for it. I'm not given it. So I'm going to be using my tangent function to solve this problem. And I set up my problem, the tangent of 27 degrees, that TOA equals my opposite, that's what I'm looking for, that's my x, over my adjacent, that's my 5. When I cross multiply, I'm going to end up with my x equals 5 times the tangent of 27, and that'll give me my answer. Of 2.55 if I'm rounding to the nearest hundredth. The last question. They're dealing with an airplane approaching a runway. They've got the glide slope as the path a plane usually takes when it's landing on a runway. The glide slope makes an angle of 3 degrees with the ground. A plane is on the glide slope and is 1 mile, which is 5,280 feet, from touchdown. We want to use the tangent to find the length EF, the plane's altitude to the nearest foot. So we know we have 3 degrees. We know we have our 5,280 is our adjacent side. We know we're looking for our x, which is our opposite side. And if I set up that tangent problem, I would write that the tangent of 3 degrees is equal to the opposite side, my x, over the 5,280 feet, my adjacent side. I need to cross multiply to find that x. So in order to calculate that, x will be 5,280 times the tangent of 3. And again, that's just a number crunching exercise. (5,280) tangent 3 gives me 276.7, rounded to the nearest foot is 277 feet.